this is Paul from DLT Trading, and today we're going to show you some of the high-tech equipment that Rick Hinderer uses to make his knives in-house.
The latest in CNC machining center technology. These are Haas DT1s, and I have them set up in a pallet. These are pallet changers, and what they do is we have different fixture plates. And these are set up to run Loctite. And we have where you can be able to take, it's like we put the titanium coupons here, and this station it drills them, and then this will come out, and that'll go in. So while that's machining, then this one is, the operator will take the old one, all the parts off, put them on here while that's machining, and then he'll hit the button on there, which turns it to automatic, and then when this is done, then that'll come out. So in other words, what it is the machine is always running. Gotcha. Whereas normally in a normal setup, I have over there, the machine gets done with that part, and then the door opens, the machine shuts off, and the person changes out the parts, and then closes the door. This here, there's no stoppage.
All right, this is the pallet changer in action. You can see it's running parts right now. Then we come on the outside here. More parts are being loaded up to be fed into the machine to keep it fed and running. Isn't that right, Logan?
That's right. These are the slippy liners. So what's in the machine right now is the left-hand side of the liner, and then these are the right-hand side. So we're running those both at the same time, and they'll just alternate on the pallets.
These are all gang tool machines. So they have, they're lathes, but they have a vertical gang tool type setup. And so we use these to make a lot of our small parts. So in other words, like this one is making the stop pins for the slippies. This is a Y-axis machine, so it's got a Y-axis. So it'll do all kinds of milling. So it's like a mill turn. So it's a lathe, but it's got C-axis, okay. Yeah. But it's got a Y-axis, so it actually it can mill like this on the plane. Whereas just the C-axis is the rotational part of the spindle. Yeah. So this is a VF3, and what makes this? I got this so I can be able to, I have a subplate on my fixture plate system, and I designed it so that I can be able to, like I can put a whole bunch of these fixture plates all over it. And we're running flippy springs on it. Must be done with them. So, but all of these go into these. It looks like first operation pens. It looked like that was investigator pen, first operation investigator pen. I can always tell by these long parabolic drills. This is an interesting machine. It's got a turret like a regular lathe, but a gang plate. So I can run 8 tools on the turret, and I can set up tools on the gang plate. The nice thing about the gang plate is I could get these long drills in. If you put long drills in here, and you start running into issues with hitting the tool with clearance.
Okay.
So putting them down here, you can see that gets them way back on the machine. So long drills work really well. This is the very first machine center that I bought. So the BMC 15. All I've ever done with it was change out servo motors, and they're on the second set of servo motors, and that's it. It's been a really good machine. This thing has made a bunch of XM18s. I learned on this machine. This was in the old shop over on and this was one of my first lathes. It's been a really good machine. I had it for probably 15 years.
What are we running on this one?
stabilizer.
Lock bar stabilizer.
Gotcha. Gotta have them.
Yep. That machine's made a lot of lock bar stabilizers the past 15 years. So, this is what they call a Swiss style Swiss style lathe. So what's really neat about it, it's got two spindles, main spindle and it's got a sub spindle, as well as a whole bunch of different turning tools and also live tools. So we can make parts start to finish in one operation. Front side, back side, everything in one operation. So right now these are the Eclipse handle screws. And that'll do all the front side and the back side in one operation. This is the finishing room. This is our
Fancy new tumbler, right?
yeah, high energy finisher, which is really cool. We use different media for different things. And
Also looks like a somewhat dirty process.
yes, it is. And there's no way you can get away from the dirty process part of it.
Yeah.
But everything we make goes through. But this is really cool. What would take that bowl out there 2 days to do, this can do in about an hour. So it's a really good machine. It does really good finishes. What this is a vision measuring machine, and it's all computerized. And what you do is you actually program the part in the machine and all of the measurements. And once everything is programmed, then literally all the operator has to do is go over here, put the part on the table, and hit measure. And it'll go in and measure all of the different things that you need measured that you program. And it'll come up here green if everything is within the tolerances that you put in. So if I put in a tolerance of, I want this hole to be not only concentric, but if I want it to be, like a half thou tolerance, I'll actually put in minus half thou plus half thou, which is actually a 1 thou tolerance. And so it'll go in and it'll read that. And if it's within that tolerance that I put in, it comes up green. And if it's out of tolerance, it'll be red. It'll have an NG, no good, and red. And it'll tell you exactly how far out it is. So an operator, when they're actually setting up the machine, they can take and look at it and say, oh, okay, we're out of tolerance by 1.5 thou. They can go to the machine and offset it to be able to get it within tolerance. So then every so many parts off the machine, they come over here and they put it on the table, and literally within seconds, they can check everything on that part. Whereas before, manually, you have to manual calipers, and then each person, uses the calipers differently. So you can have different. So this way, anybody checking that, whether I check it, you check it, or anybody else checks it, you're always going to get the same measurement. Our accuracy and quality went up tremendously when we bought this. This is a very, very expensive machine, but it was totally worth it in the sense of how our quality went up. And that's what I want to kind of get out there is when people buy a Hinderer knife, this is what they're buying. It's $425, but this is $50,000 here to check, make sure it's perfect. You got a $100,000 machine that's making the parts. All of this goes into that, and that's the reason why when we got it, that's why the quality is there, is because of stuff that I invested in to make sure. Because when I started growing and I got more and more production, more knives out, the thing that kind of happens with some companies is production goes up, quality goes down because you're making more, so you have a chance of, checking is kind of hard. So what I did was to maintain that quality, or actually even make it better, what I did was I invested in stuff like this to be able to keep that quality up. And because my name goes on each and every one, so it's got to be right.
Yeah. What it's doing is it's picking up all critical dimensions on the blade, all the hole locations. So if we see any red, and if we're allowed up to like a half thou in red. After that, then we got to mark the parts not being good.
Okay.
So we're going to put the part in, and we're going to measure, and that would be a good part.
And we're coming up all green across the board.
Right.
And how often do you measure parts?
I'm measuring every blade that comes off of there.
Wow.
So when I get 4 parts off, it comes over here and it gets measured.
So that's going to do it for part 1. We do have a couple follow-up videos to this. One of them is going to be taking the knife from the parts that you just saw made to final assembly and how it goes from there. And we also have a fun outside the shop video that we're going to do as well. So thanks for watching, everyone. We'll see you next time.